Good afternoon, class. I don't see anybody in here right now, but I'm going to go ahead and get started. We're starting a new cycle now, so remember at the beginning of the cycle, cycle 2, you'll have a cycle 2 self-assessment looking ahead. You want to make sure you complete that. That'll be due next Monday. And we're going to do 3 sections this week. And so the first section talks about basic exponent rules, and they actually mention in here working with area and perimeter because those, especially area, work with exponents. And again, in this section, we're going to go through the different exponent rules, and we're again going to use geometry formulas to find perimeter, area, volume, and so forth, because commonly in those calculations, there's units involved, and we may forget about the units until the very end. So we want to think about what we can do to avoid leaving off the units. And so it's probably good to keep the units through the calculations. So thinking about the kind of calculation you're doing too will help you determine, for instance, if you're doing area, you have square units, and if you're doing perimeter, you have the linear or the original units. So remember now, exponents are used to condense the way that we do repeated multiplication. So if we're writing 2 times 2 times 2 times 2, we can simplify that and write it using an exponent with 2 to the 4th, where 2 is what we call the base, the factor that we're repeating, and 4 is the exponent, and it's the number of times that we're multiplying the factor together. If you look on page 179 in your book, it's a little small on the screen here, but the rules are there for working with exponents. And there are 6 rules that your book gives, and you want to make sure you review those when you're working on the problems in this section. So here we go. Let's look at some problems. So here we're multiplying 2 numbers that have the same base. We're going to multiply the coefficients, and what are we going to do when we have the same base? We're going to add the exponents. So in this case, we're going to get 34x to the 7th. And if we go to this one here, we're taking a power to a power, so we can actually distribute that. So we're going to get 4 squared, or 16, and then a power to a power multiplies the exponent. So we get 16x to the 8th. Likewise on this one, the thing to be careful of here is the -5 is going to be squared, and it's going to give us 25x to the 6th. Notice it becomes positive. Here we're doing a -8. This is the base. Any base raised to the 0 power other than 0 equals 1. Notice the difference between D and E. Here the negative is outside, so that means we're first going to raise 8 to the 1 power, to the 0 power rather, and then apply the negative, so it's -1. Here are 2 ways you could work this. You could simplify within the parentheses first, or you could go ahead and distribute the exponent to the numerator and denominator and then simplify. I think I want to simplify first. So if I go inside here, I see that 3 divides into 6 2 times, so I can put a 2 down here. And then I see x to the 4, and remember when we divide bases with this, a number of quantities with the same base, we subtract the exponent. So 4 minus 3 is going to give me x to the 1. And then if I go ahead and distribute my powers, what am I going to get? My exponent on the outside. I'm going to get x squared. Notice this with x to the 1 here, and then I square it. And then in the denominator, I've got 2 squared root of 4. Same thing over here. Here I could just go ahead and distribute in the numerator. And when I do that, let me get my pen up here again. When I distribute the square in the numerator, I'm going to get 9, 3 squared, and then I'm going to have x squared, y to the 4th. Okay, and then I can go ahead and simplify between the numerator and denominator. 3 goes into 9 3 times, and the x squared is going to stay. This is going to be y to the 4th minus the 4 minus 3 is going to give me a y, so my final answer there is going to be 3x squared y. And then here I would want to square this portion first. So when I do that, remember in order of operations we always do exponents first. So I'm going to get 8, and then I've got x, and 2 raised to the 2 power gives me a 4. And then I've got y also to the 4, and then I've got a z squared. And then I can go ahead and multiply, and let's see on my coefficients, I've got 8 times 8 is going to be 64. I'm sorry, 4 squared is 16. Let me go back on my pen. This is a 16, my apologies. Raise it to the power 16. So I'm going to have 8 times 16, and then I'll have x. Let me go ahead and get to the next. So 8 times 16 gives me 128. I've got x to the 1, x to the 4 gives me x to the 5. Y to the 1, y to the 4 gives me y to the 5. Z to the 1, z squared gives me z cubed. Okay, find the area of a triangle whose base is 5 inches and the height is 20 and include the units in your work. So if you look at the handout that we had from Cycle 1, which had the geometry formulas, we know the area of a triangle is 1/2 of the base times the height. And in this case, the base is 5 and the height is 20. Now I'm keeping my units along the way here, so I notice that when I simplify here, I'm going to get 5 times 20 is 100 divided by 2 gives me 50. Inches times inches gives me inches squared. Find the area of a square whose sides have length of 3 centimeters. Why do you think 3 squared is 3 to the 2 power is sometimes written as 3 squared? Okay, so 3 times 3 is going to give me 9 square centimeters. And again, this gives us the area of a square with sides of length 3. Okay, the second section we're going to do this week is called adding polynomials. And we want to talk about what like terms are. They have the same variables raised to the same exponents. They do not have to have the same coefficients though. So for instance, if I look at these two terms, 3xy and 4xy are the same because the variable portion is identical. So if I wanted to add those together, I would simply do 3 plus 4 or 7xy. These terms are not like terms. They have the same variables, but they're not raised to the same exponents, so I cannot add those together. I can't simplify those at all. Can't combine them. So often an expression will be given with a brief direction, simplify. The one word can have many meanings. In general, it means to perform the given operations to shorten or condense the expression. To simplify or combine terms, the coefficients are added, but the object does not change. So for instance, if we take a look at this problem here, we see we have 2 x terms and we have 2 y terms. So we're going to combine those terms. So of the 4 terms, 2 have an x variable factor and 2 have a y variable factor. We can use color or symbols such as boxes or circles to make the symbols or the terms distinguishable. So this term and this term are the same, and I can go ahead and reorder these so I see them next to one another and I can simplify them or add them together. And this term and this term are the same terms. So again, I can take 7x minus 3x gives me 4x. 2x minus 4x gives me, 2y, minus 4y gives me negative 2y. So once we've identified the like terms, we can combine them, that is, to add them. Reading the expression in words helps sometimes to simplify it. 7x's plus 2y's minus 3x's minus 4y's. And add the coefficients and we leave the variable factors alone. I'm sorry, this is moved over, so we get depending on which variable's listed first, we can have 4x minus 2y or 2y plus 4x. It doesn't matter. Either one is going to be a correct answer. So how it works on page 186, identify the like terms and then add the coefficients of the like terms. We keep the variable factors the same. In each problem, identify the like terms and then simplify by combining the terms. So let's look at this first one. We have 2 like terms here, the a terms. So we can combine those to get negative 8a plus 23. All right, in this problem here, we've got an x squared and an x squared. We've got a y and a y, and then we've got a single x term. So we're going to combine the squared terms. 8 plus 16 gives me 24x squared. 4y plus 8y gives me 12y, and then I still have the negative 12x. All right, in this one, I've got a w squared, and a w squared, and I've got a w, and then I've got a single constant term. So I'm going to go ahead and combine the w squareds. So this w squared and this w squared. And this w squared and this w squared. I'm looking at the wrong term. So it's 17 minus 3 halves gets me 29 halves w squared. And then for the w terms, I've got negative 1 plus a quarter, so negative 3/4 w, and then I still have the negative 1. Some more to look at here. Now in this case, this is a square root sign, which actually can be written as a fractional exponent, which we don't cover in this course, but this is the variable portion of it, and it's identical, so we can add the coefficients to get 8 square root of x. All right, in this problem, I've got 2 xy terms, which can be combined, and I've got 2 x terms, which can be combined. And then in this one, I've got constants, which can be combined, and I've got a term with a letter called I on it, and those would also be like terms. So I've got 3 minus 7 is going to be given negative 4, 4i minus 9i is going to give me negative 5i. some more to simplify. So here, I'm multiplying. Now look at the difference in these. Some of these look the same. These both have x cubes in them, but this is a multiplication problem. So what do? I multiply the coefficients to get 16, and then I multiply the terms with the exponents. They have the same base, so I add the exponents, so I get 16x squared. Notice the difference here. I'm adding the two terms. Remember, when I add two terms, I can only, if they're like terms, where the variable portion is identical, I'm going to add the coefficients and get 8x cubed. Remember, the x cubed part does not change. Again here, I'm multiplying. So I'm going to multiply 4 times 4 gives me 16. When there is no coefficient next to the variable, we know that's the coefficient of 1. So we're going to get here 16x to the 4th. And then notice the difference in D, we're subtracting. Now these are not like terms, so we cannot combine them, and the answer is the same as what we started with. These are not like terms. This is an x cubed term and this is an x term. We can't combine them, so our simplified answer is the same as the original problem. Find the amount of edging needed for a rectangular deck that is 76 centimeters by 46 centimeters. So we're doing edging around that, so that's going to be the perimeter, so we're just going to go ahead and add all those numbers up. And notice the units are still in the original units because we're doing a linear measurement here. So 244 centimeters. Okay, and then last section for this week is order of operations. So most students remember order of operations. To guarantee there's only one correct answer for a calculation, the operations are going to be done in this order. Operations inside of brackets, parentheses, or other grouping symbols are done first. Then we do exponents and roots. And then we do multiplication and division from left to right in the order in which they appear. Multiplication is not done before division. It depends on what we see first, moving left to right. And then we do the additions and subtractions, again left to right in the order in which they appear. And many students learn PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Okay, so let's take a look at a problem. We want to do order of operations here. So what are we going to do first? We notice that the division bar is actually a grouping symbol. So we're going to do simplify the numerator and then do the division at the end. All right, and so we need to look up here. We've got an exponent, so this would be what we would work on first, that 4 squared. So we're going to apply the exponent. 4 squared is 16. Now order of operations tells me I'm going to multiply next. And now I'm going to simplify the numerator. We're going to subtract in the numerator. And then we're done. So there are no common factors between 1, 10, and 3 other than 1, so this is a simplified fraction. Simplify each expression using the correct order of operations. So here we've got 4 minus negative 3. The parentheses here are simply to tell us that this is a negative number. There's not any implied operation inside there. And if you remember, one of the things we said is we can change subtraction into adding the opposite, and so that answer is simply going to be 7. All right, in this case, we want to simplify 4 minus the absolute value of negative 3 is 3, so 4 minus 3 is 1. Notice in C, the parenthesis here does tell us something important, that the negative is part of the base. So this is going to become 4 minus 9 or negative 5. And here we want to simplify inside the parentheses first and then square it. And again, this is like the first problem, so it's going to become 7, and 7 squared is 49. So here's how it works on page 192. Again, talks about starting with the grouping symbols, then do the exponents and the roots, and then multiplication, division, and then addition and subtraction. So let's try a couple more. So here we're going to do the exponent first. 5 squared is 25 plus 3, 28. Here we want to simplify inside of the parentheses. So we go 2 minus 6 gives us negative 4. Still in the parentheses, we're going to square that, which is going to give us 16. 16 times 3 is 48. 7 minus 48 gives me negative 41. On this problem here, square root sign is like a grouping symbol. We want to simplify inside first. 2 squared is 4. 4 times 16 is 64. The square root of 64 is 8. 8 divided by 4 is 2. 4 cubed is going to be 4 times 4 times 4 is 64 rather. 64 minus 2 is 62. Again, on this one, we want to simplify inside of the square root sign first. 4 times 3 is 12. 24, negative and negative gives me a positive. So this becomes the square root of 25 plus 24 is 49. So in the numerator, I have negative 4 plus square root of 49 is 7, which gives me negative 3. This becomes a positive 3 over 2. This becomes 7. Negative 4 plus 7 gives me positive 3 divided by 2. In this section, you're also going to learn about evaluating an expression. So they'll give you an algebraic expression, and they'll give you some values for the variables and say evaluate it when the variable equals this. And in this case, we're going to evaluate when x equals negative 2. So in that expression, wherever I see x, I'm going to put in a negative 2, and I want to simplify it. So negative 2, I do the exponent first is 4. 4 times 3 is 12, so I've got 2 minus 12 over 2. Negative 10 over 2, and I end up with an answer of negative 5. So to evaluate a formula or an expression, replace the variables with the appropriate numerical values, and then use order of operations to simplify, and make sure you use units if units were given to you. So let's take a look at this question here. This is a formula for the future value of an investment if you invest P dollars at an interest rate of R as a decimal. The variable N is the number of times a year the interest is compounded. T is the time in number of years. Assume you have $1,000 to invest. That's going to be my principal. Invest it at an interest rate of 3 5/8%, compound it monthly. How much will you have after 20 years? Okay, so here's my variables to go into the expression. P is 1,000. My interest rate is a decimal. I took 5 divided by 8, added to 3, and then divided by 100. So if I substitute into the formula, now when you're working with a formula like this, which looks pretty complicated, where you're going to start is right here. You need to simplify inside the parentheses before you can raise it to the exponent. So I'm going to take this, divide it by 12, which I did here, and then I'm going to add 1. In my calculator, I can do this all in a series of strokes. Now I'm going to take the number that's in my calculator and raise it to the 12 times 20, or 240th power. You need to find on your calculator where that exponent key is. It's generally a key like, it might have a little caret like that, we call it. It might have a key that's called y to the x. It depends on your calculator. Raise that 1.003 to the power, and then last thing you're going to do is multiply by the principal. So in this case, at $1,000 at this interest rate, compound it monthly for 20 years, will result in $2,062.48. Try another one. This is a formula for a mortgage payment, monthly payment. M is the amount of the monthly payment. P is the amount we borrowed. Again, N is the number of payments per year, which is generally 12. T is the number of years for the mortgage, and R is the interest rate as a decimal. So let's try a problem. So we want to do the monthly payment for a loan of $150,000 at 4.1% for 30 years. All right, so the principal is $150,000. Interest rate 0.041. Monthly means 12 payments per year, so N is 12, and we're going for 30 years. So here's my formula. I'm going to put my numbers in. All I did was replace the numbers. Now again, I'm going to simplify the numerator and denominator separately and divide at the very end. So the first thing again I'm going to do is divide this by this, this by this, this by this. So again, and now I've got what I just said, I divided, did those divisions. Now I'm going to add 1 to the number here, 1 to the number here in the next step. Then I'm going to raise it to the exponent, which is 360 in both the numerator and the denominator. And then lastly, I need to subtract in the denominator. And then last thing I'm going to do is take numerator, divide it by denominator, and then multiply by the 150,000. So the mortgage payment for the $150,000 mortgage at 4.1% interest for 30 years is $724, and we'd round it up to 80 cents. So although these mathematical formulas look complicated, if you do them step by step, you shouldn't have any trouble. And again, remembering the order of operations, which is so critical so that you will get the correct answer to the problem. So hopefully this will help you with the first 3 sections of Cycle 2. And again, don't forget to do that Cycle 2 self-assessment looking ahead at the beginning of the cycle.